So I'm going to be talking about basic and advanced SQL injection techniques. Basically, I'm going to hope that you don't necessarily have to have a familiarity with SQL injections. I'm hoping that the basic part of this talk covers and is able to fill gaps in maybe understandings of what SQL injections are. And then the second half of the talk, we're going to go over some real-world examples of where we needed to use some advanced SQL injection techniques in order to actually glean information out of the database or pop a shell, run code, things like that. Now that it's, give me 4 seconds and I'm going to wait just. All right, 4:30. What are SQL injections? SQL injections, generally speaking, are a programming error on behalf of programmers. Sometimes it's not the case. The last example we have in this talk is not a programming error on behalf of the programmer per se, the guy who wrote the code. And sometimes frameworks are vulnerable to SQL injections where the programmer did everything correctly. But the framework that the guy was using implemented something incorrectly, and that caused the code that the programmer wrote to be insecure or vulnerable to a SQL injection. SQL injections modify SQL queries so that they either return unexpected data or they modify the behavior of the application in a way that allows you to glean information from the database. And SQL injections, they are the scourge of the earth. We have been dealing with this problem perhaps close to 30 years at this point. I don't actually know because I wasn't around 30 years ago. But at least since I've been writing web applications since the mid-early 2000s, SQL injections have been a big problem. I think Rainforest Puppy in the 90s also really wrote a good talk or a write-up on early SQL injections. Okay, so let's talk about some major types of SQL injections that are generally exploitable by attackers. So you have stacked SQL injections. What is a stacked SQL injection? Let's take an example like this. So we have a URL, example.com/index.php ID equals 1. The ID equals 1 is the part that the attacker can control that's going into the SQL query. And let's just pretend that that 1 in the URL at the very end is, let's see. Let's pretend that the 1 at the URL at the very end is also being dropped into this SQL query down at the bottom. So select all from table where ID equals 1. If this query string parameter were vulnerable to a stacked SQL injection, we would be able to put a value like this, which would use a semicolon. I even have a fancy thing right here. Yeah, there we go. So I have a semicolon between the 1 and then the rest of the SQL query, which is select sleep 5. So this is a stacked SQL injection that would cause the response of the SQL server, or the response from the HTTP server, to go on by 5 seconds more than it would otherwise. So that turns, so if we pass this URL to the in our web browser, the GET request is made to the server, that turns that SQL query on the back end into this. Select all from table where ID equals 1, semicolon, select sleep 5. And these are particularly bad types of SQL injections because they allow you to append any SQL you want to the end of the original SQL query, effectively allowing you to delete any of the data in the database if you would like by appending a delete from SQL query. Insert your own admin users into the database using an insert query. Stacked queries are quite powerful, but sometimes they're difficult to glean information out of the database. They're a lot easier to modify. They're a lot easier to use to modify information in the database as opposed to glean. Another type of SQL injection is a Boolean type SQL injection. A Boolean injection, let's take the exact same example we had before, where we have a URL with an ID of 1 in the parameter, and then the SQL query that we're going to be running with that ID that we're supplying in the query string. So let's say I pass in a value of ID equals 1 or username equals bperry. Then that turns into, on the back end, select all from table where ID equals 1 or username equals bperry. Boolean attacks and SQL injections allow you to modify the behavior of the SQL query using true or false statements. And that can allow you to glean information out of the database, generally a byte at a time. But you don't always have to glean information out of a database using Boolean attacks. So let's see if we can get this working on this screen. I'm going to do it from down here. Okay. So welcome to Bad Store. Oh no, that's not Bad Store. This is a vulnerable web application that has many vulnerable SQL injections, XSS, things like that. This is a great little vulnerable web application for testing on and things like that. So we have a login form here, right? Put my FDSA password right there. User ID and password not found. Okay, so I don't have credentials for this web application, but I really, really, really want to get into it, and I want to be the admin user when I do it. If I do FDSA apostrophe and then do FDSA in the password, we see that I get a SQL syntax error that's displayed to the screen. This is a very, very classic indicator that this parameter is going to be vulnerable to a SQL injection. If you ever see errors like this show up on your websites you use online, you should just stop using that website because your information is going to be compromised. Okay, so we know that that login prompt there is vulnerable to a SQL injection. I'm going to go ahead, if I pass in something like FDSA or email equals admin with a hashtag at the very end, that's a comment in MySQL parlance, and then hit enter, you notice I'm now welcome master systems administrator because okay, so what just happened? I was able to modify the SQL query to make to authenticate as a user that I didn't necessarily have the credentials for. So let's take the SQL query that was possibly run on the back end, select all from users where name equals bperry and password equals the password that I wanted to authenticate with. I can control the bperry part inside the SQL query, but I can also control the pass part. I don't actually care about the latter part though. The only part that matters is the fact that I control the value that's being inserted into the I have a pointer. Sometimes, there it goes. So I can control this part right here. So what happens if I supply a username that looks like this? bperry or email equals admin. That's what I just did, right? It turns the SQL query on the back end into select all from users where email equals bperry or email equals admin, and then it comments out the rest. You can kind of see it's very dark blue. I may not be able to use this pointer very, very much. I think the battery's almost dead. So that is a classic example of being able to use a SQL injection to perform an authentication bypass using a Boolean attack, basically modifying the SQL query on the back end to always return a user that you want to be able to authenticate as. And so that basically means the very last Boolean syntax at the very end is going to be returning true. Email equals admin. I know that there's an admin user in the database with an email, with that as their username. So that's an example of a Boolean-based attack. Okay, so unions. A union-based attack is very, if we have mathematicians or people that work with data sets in the audience, you'll understand that unions bring data sets together, right? So you have a union, or you have a data set over here, and you union them together to bring the data sets together so that they are now a single data set. Let's take the original example we have. We have an ID of 1 in the query string, and then this SQL query at the very bottom, select all from table where ID equals 1. A typical union attack may have me appending a union statement to the end of the original SQL query on the back end using the HTTP parameter. And this is an example of what that SQL query, or that syntax at the very end of the SQL query may look like. Union select null email password null from users. What that may look like in the URL bar, we do ID union select null email password null from users. This is a 4-column union, if you know what you're looking at. And what this does is it turns the SQL query down on the bottom to select all from table where, so let's assume the users table, or the table that we're selecting all from has 4 columns in it. If I were to append 1 union select null email password null from users, any data from the first select statement is going to be joined with any of the data that I pull out of the users table through that union. So if I'm displaying that information in a table on a web application, the new information is going to show up. So let's demo that real quick. Okay, so we're back to bad store. I'm going to go to the home real quick. And I'm just going to do a quick search. And this may be a little bit difficult to see on the big screen in the URL, and so I'm sorry about that. But basically, we've got this URL bar up here that has a search query equals FDSA. And if I put an apostrophe into the value, I get a SQL syntax error. So this search query parameter is obviously vulnerable to a SQL injection. Let's go back to this. This SQL injection is vulnerable to a 4-column union SQL injection. Let's see if I can do this just by looking at it. Let's see. Union select null email password null. %23. No, that didn't work. Hold on. Oh, that's because I left out my apostrophe. So basically what you're doing when you're exploiting SQL injections is you are breaking in and out of strings or potentially non-strings if it's an integer in the SQL query. Email, unknown column. Oh, I'm sorry. It's from UserDB. I actually have this set up in a Burp Suite thing, but I decided to try and do it live because, right? From UserDB. I say it's supposed to work. I swear I tested this before I did it. I may just pull out Burp Suite real quick. Let me just pull up Burp Suite. It's right behind here. And I'm just going to copy the URL out of it because I know it works there. Burp Suite Union. Yep. Okay. So let's see if I can do this. Okay. So if you guys can see that, that looks a little bit better. This is the URL that I'm about to go to. FDSA union select null email password null from UserDB. If I copy that URL and then go to Firefox, I think I can go to Firefox. Let me. I just learned how to Mac the other day, so give me a minute. There we go. Firefox. Except it didn't come up on the right screen. There we go. Okay, so I'm going to copy and paste this back in here. Sorry. Did not work out as well as I'd hoped. There we go. Okay, so this is what happens when you exploit a unionable SQL injection. Sometimes it doesn't work nearly this easily, but this is exactly how Sony got hacked, guys. I made a single HTTP request, and I was able to union the data set from the database that the users, or from the table that the users were stored in, with the SQL query that was being run to select products from the database. So I was able to use a union to basically pull all of the users out of the database and have it displayed on the screen for me with a single HTTP request. I was able to get all of the users and their password hashes, and obviously Kevin doesn't have a password hash. I wonder what that means. But this is an example of a union-based SQL injection and just how powerful and destructive they can be. If an attacker is able to find a unionable SQL injection on your website, then it's very, very simple to literally dump all of the data in your database with very, very few HTTP requests. Not noisy, very, very easy for attackers to get away with it and to cover their tracks. Okay, and then the last type that we're not going to cover real quick is an error-based SQL injection. And this is a result, as you can see in the bad store SQL injections, errors are being persisted to the screen. If I just put an apostrophe inside the search query here, then I get a SQL error that's coming out that's being displayed to the user. You should never be shipping products that display errors to users to begin with, let alone leaving debug things enabled, because you never know what that server is going to be displaying back to the user. You don't know if it's going to be user controlled or not. And so using an error-based SQL injection, you can actually cause errors to come back with values from the database that weren't necessarily going to be there to begin with. Okay, so let's move on to some real-world examples. Let's do WordPress photo gallery. This is I don't know, 2 years old or something like that. I think it's photo gallery 1.2.7. It's a Boolean-based SQL injection, but by default, SQL Map is unable to exploit it. SQL Map will detect that it's vulnerable, but it can't exploit it. So let's see what that's going to look like. Okay, so we've got this HTTP request right here. It's a GET HTTP request, and if I hit go, let's make sure it still works. Yes, it does. We get back, so this is /WordPress/WP admin. This is just a basic HTTP request that's being made by the vulnerable, to the vulnerable endpoint on the plugin. The SQL, the order by parameter is what's vulnerable to SQL injection. So you can see it's order by ascending. That's being just dropped straight into the SQL query. So let's see. I've got the SQL map right here. Yes. Okay, so let's maximize that. Run that. So we can see that SQL map was able to detect two types of SQL injections inside of this HTTP request, and a Boolean-based and then a time-based. And I would argue time-based is a Boolean-based type of SQL injection because you're using true or false answers to determine HTTP response times as opposed to data that's being returned back from the HTTP server. But if we try and exploit it, DBs, for instance, which will try and enumerate the databases, it fails. It cannot actually enumerate any of the databases that are on the server. And at first glance, you're not sure why. So let's go and let's look at the error logs for Apache on that host. I think. I'm pretty sure I'm going to be able to. Yeah, there we go. Okay. Go over there. Yeah. Okay, so let me log in here real quick. Password's password. So let's exit here. cd/var/log/Apache. I think that's right. Yeah. And then cat error.log tail in 1. Okay, so this is the last error that happened on the web application. Let's look at it. It says it's obvious that there's an error in our SQL syntax. If we look through it, if we're trying to do a Boolean attack, that means that we're going to be asking true or false questions. We're either asking if something is greater than or less than something, does something equal something, things like that. So let's look if we look here, we'll notice we have ampersand GT semicolon instead of a greater than or less than character. This is because on the server side, there's some sort of HTML encoding that's happening on the payload that I'm trying to get the SQL server to run. It's probably unintentional. I highly doubt that this was their solution to a SQL injection problem. I really hope it's not. But in any case, it's very easy to get around this. So we can go back to SQL Map, and SQL Map has what are called tamper scripts that it ships with. Let's go ls tamper. And you can see there are all these Python scripts inside of the tampers directory that allow you to define special things that changes to the syntax for the SQL syntax that are going to be sent in the payloads to get around encoding issues, possibly rate limiting. You've got things like space to hash, space to dash. Between is the one that we actually care about. So what we're going to do is we're going to do -- tamper equals between. And I'm going to show you what actually happens. Aha, so now we can actually start getting data out of the database using the tamper script, tamper equals between. So before I get too far with that, let's look and see what that actually looks like. What is SQL Map doing there so that it can exploit it the second time but not the first? Okay, so I've got my stuff going through Burp Suite now, and if we look, we're getting all these HTTP requests going through Burp Suite. Let's look at this HTTP request right here. URL decode this. Convert selection, URL decode. And we'll notice that now, instead of using a less than or greater than sign, we're using not between 0 and 104, which is functionally asking, are you less than 104, right? So now instead of using a greater than or less than character, they're using a special MySQL syntax in order to ask the same functional questions to the server without using a greater than or less than character. So that is one example of being able to say, SQL Map can't actually exploit this by default, but there are certain ways to, different syntaxes you can use to ask the server functionally the same questions and get the same results out. Okay, so WordPress Boolean-based SQL Map can't exploit it by default. The next one we're going to talk about is this one right here that I'm pretty sure I told the guys about it, and I'm pretty sure they fixed it, but I don't know for a fact. I told them about a bunch of other stuff as well, so I don't know. Anyway, so this Joomla OS property is unionable. We're able to perform a union-based injection on it. Multiple weaknesses on this actual appliance allow me to make a greater foothold than I would otherwise. I'm not going to be able to just read information from the database. I'm actually going to be able to write data to the file system, specifically the web root, which allows me to pop a shell, execute remote code, things like that. The reason that happens, let's just go here. We will go to the repeater. Let's go to Joomla OS property. So I'm going to open up Joomla real quick on the Firefox right here. And you'll notice this looks like a totally empty Joomla installation, right? It doesn't look like there's anything here. However, there is a vulnerable plugin installed that is still accepting HTTP requests as to an unauthenticated user in regards to the Joomla OS property plugin that has been installed on the Joomla installation. So that does not, just because you don't see anything here and nothing is there that allows me to click on it, it is still absolutely an exploitable SQL injection. If I go here and I do a go, we notice that I still get my HTTP request back. And then we can go to SQL map. There we go. Nope, not yet. There we nope. Got it here somewhere. There we go. Okay, go to SQL map, and we know SQL map is able to detect quite a few different techniques that we're able to exploit this with. Boolean-based, error-based, time-based, and union-based. However, the only one we actually care about is union. So let's go a little bit of a background into this application. If we go to the web root, oh, that's not the right one. Sorry, I've got like 8 virtual machines running on my thing right now. That's the one I want. Yeah. Okay, password. When, as a web application, someone who audits web applications, you don't necessarily just have to focus on the web application part. If we cd ... oh, that's not what I meant to do. God damn it. Okay. And do LSAL, you'll notice that HTML, the HTML file, which is /var/www/html, which is the default web root on Ubuntu, it's owned by www-data. However, it's chmodded 777. So anybody who has access to that system can technically write to /var/www /html. And this is a common misconfiguration because it's so much easier to just do chmod r777 /var/www than it is to go and find out what user my web server is running as, go and run the correct chown directory. It's only an extra command, right? But web application developers are lazy and they will actually deploy this type of thing in production. But what this actually means is that if I have a SQL injection, for instance, I can use the dump file keyword from MySQL to actually write files to the file system as the MySQL user, and then I can actually write to the /var/www file directory as the MySQL user, and then achieve remote code execution. So let's go back over here. We know that we have a vulnerable SQL injection. If we do --dbs, it pulls data out very, very quickly. That was not actually cached. So it literally pulled those 4 databases out probably with a single HTTP request. However, we should be able to write a file with no problem. So let's, I'm going to show you what my file contents are going to be. /temp/ oh, and I also want to do this just so I can prove that this file didn't exist before I made the HTTP request. So I'm going to write /issw.php to the file system. And that should not fit. Okay, well, let me go remove that real quick because that was supposed to be removed. It's almost as if I didn't prepare. Where'd you go? Yeah, okay, so cd html rm issw.php. Okay, so now you know for a fact I've removed it. Let's go to Firefox real quick just to make sure that's a 404. Yeah, okay. So now we can go into, we can exploit this union injectable SQL injection with a very special payload. So let's look at what this payload looks like real quick. And you notice I'm passing in a negative ID. The reason that I do this is because if I select all where blah blah equals -1, that should, if all indexes are 0-based, I'm never going to get any data out of the database back. So that just keeps me from accidentally selecting data that I don't want to select. Union all select, this long hexadecimal string right here is my PHP file that I want to write hex encoded. What does my PHP file look like? If I cat/temp/php-info.php, you'll notice it is a very, very, very simple PHP file. All it does is call PHP info, and I mean this is a perfect example just to demonstrate being able to achieve remote code execution via a SQL injection technique. So if I go and I upload, so I can use the dump file union all select null into dump file. So this into dump file is the actual clause in the SQL query that we care about. This is telling SQL map, or this is telling MySQL, any data that comes out of this set, any data that's in this set, go ahead, instead of returning it to the user, write it into this file, /var/www/html/issw.php. So let's see what happens when we do that. Oh my gosh, come on. There we go. I think that's going to work. Okay, so that brought a 200 back, which means it probably worked. And so now we do a get to that, and our PHP info page comes up. So this is an instance where, yes, we had a SQL injection that gave us access to the database, but because of one extra weakness on the file system, an ability for any user to write to that directory, the web root, the MySQL user was able to take advantage of the fact that I can write there, and through a SQL injection, which normally would only have me read access, I was able to gain write access to the actual system itself by writing a file as the MySQL user to the web root. Okay. So I don't know why it keeps going back to there. Okay, so union-based technique also usable. Multiple weaknesses. So this is just one thing. When you're auditing network appliances, for instance, this is a very common misconfiguration. Not only is everything running as root, generally speaking, on these network appliances, maybe if they did it correctly and everything's not running as root, file system permissions are often another second way to get a foothold as another user. You may be able to write information to a directory that allows you to elevate your privileges. Okay, so vanilla forums. This one's a pretty interesting SQL injection, and this is the most complicated one that we're going to do. Oh, and one thing I wanted to note, that unionable SQL injection that we just did, if you had taken my training, you totally would have written a Metasploit module that exploited it and popped a shell using the Materpreter PHP. So, stupid plug there. Okay, vanilla forms. Again, if you took my training this week, you would have written a Metasploit module that exploited this. This is a second-order SQL injection. You can technically get away with exploiting it via there's just a first order, but to fully exploit it, you actually require a second HTTP request. The vulnerability requires changing HTTP parameter types. Because the PHP application is weakly typed, you can actually dictate the type that the HTTP parameter is going to be interpreted as on the server side. And it is partially exploitable with SQL map. We will end up exploiting it fully, and I'm going to show you how to partially exploit it with SQL map here. Okay, so this is vanilla forums. This vulnerability is about 2 years old. It got fixed about 2 years ago. However, it's an excellent demonstration of multiple vulnerabilities coming together and allowing you to really take advantage of the vulnerable system at hand. So as a user, let me sign in real quick as admin. It doesn't really matter what user I am. I could be whatever user I wanted. So as a user, I am allowed to send and receive private messages from other users. As you can see, during our training, we sent and received quite a few different messages to each other. Some of them have usernames and password hashes in them, if that's kind of showing you what's going to come. This is just a simple private threaded discussion between me and the system user, whoever system is. If I go, am I capturing on Burp Suite at the moment? Oh, that's not what I wanted. No. Okay, so if I go here and I capture this HTTP request real quick, you'll see here is what the HTTP request looks like that's being sent to the server in order for me to post a message to this thread. It's a post request, posting it to the /messages/add message endpoint. So this is kind of a pseudo route type thing that they do for Apache servers that don't have mod read write enabled. And then you have the conversation ID, the body. This is the text that's going to be posted. And let's just go ahead and let it do its thing. And if you note, now I have an FDSA right here. Okay, so let's go back to Burp Suite. And I have my repeater here, vanilla second order raw. Okay, so let's look at this HTTP request for a second. We've got a few things here. We've got the conversation ID. There's actually multiple vulnerabilities, and this is a SQL injection talk. However, there's actually a direct object reference vulnerability inside of this HTTP request as well. The conversation ID here is blindly trusted by the server. So it's an integer. You could just start from 0 and work your way all the way up and make an HTTP request, posting the same message in all of those threads by just incrementing the conversation ID, right? So that's another example of a vulnerability, very, very common in web applications. However, okay, so that's not why we're here. We're here to exploit SQL injections. This web application is written in PHP. PHP is a weakly typed programming language, which means you can be a string. You can be a string over here, and then this variable gets redefined so that it's an int over here. And PHP does not care whether it's a string or an int. It's just going to do equality checks to the best of its ability. Usually, it's not very good, but that's the way PHP works. Modern web application frameworks actually allow the attackers to dictate the type of the HTTP parameter to change it from a string, let's say, to an array by using open square bracket, close square bracket. So now on the back end of the server, this body HTTP parameter is going to be interpreted as an array with a single string inside. If I duplicated body like this, did control C and V like that, and if I had 2 body parameters, I would now have an array on the back end with 2 strings, each with a value of FDSA. So that's how these modern web frameworks are taking these HTTP parameters and kind of doing a convention over configuration, kind of trying to interpret what these things are going to be for the programmer. But that's not necessarily always in the best interest of the programmer, because the programmer may not realize what the code he writes that does. Okay, so we do that. Let's submit that HTTP request. But again, so we got a 200 back. That didn't modify the behavior of the web application. Changing it to an array was just fine. And if we refresh, we'll have our another message at the very bottom here with root, which is exactly what the value of body was. But we can do one more. Let's put FDSA as the inside of the square brackets and then send that HTTP request. Oh, and now we get a SQL error. What happened? So adding that FDSA into those square brackets, it is no longer just an array of strings, but it is now an array of key value pairs with FDSA as the key and root as the value. At some point, some programmer who rolled their own SQL query generation code decided to say, if the value passed into this function is a string, just use it as a string inside this insert statement, which is what it is. It's an insert statement if you can't tell from this insert GD in conversation, and then these are the values that are being inserted. Okay, so I'm going to pass a string, and it's going to persist a string. But if the programmer passes me a key value pair, I'm going to use the value of the key as the function that's going to be called on the value on the SQL server side. So if you look inside this SQL query, the error, you notice that the body, PDO, so this is using PDO, which is PHP data objects, which allows you to kind of more safely create SQL queries that are going to be persisted based on PHP objects. Notice that the body is wrapped in the FDSA function. So I can control this entire SQL query from where I can define this FDSA function. Okay, so let's go here, second order injected. So if we end up writing a payload that works for this, we have to actually complete the entire SQL query again, because we have to, since it's an insert statement, we have to insert the number of columns that are being inserted on the left side of the insert. So you've got 2 sides of the insert clause. You've got the side that says where I'm inserting, and then you've got the side that says what I'm inserting. So you've got insert into table values, blah. I control the values, but I have to have my values match what I'm inserting into so that the database doesn't, otherwise it's just going to error out. So what I do is I took that error that we saw in the last one, and I basically used it to just recreate the SQL query, ignoring the body part. So if you look, you'll notice that now instead of doing, instead of saving the value of the body that I'm going to be persisting, I just do select 1 from dual, which should provide me the value of 1 as the body of my comment, as opposed to this root right here. And then after that, after this subquery, I define a subquery that brings me back the value of my body. I define the rest of the PDO statement as if it were being run on the back end. So I define each one of the parts of the SQL query that needs to be inserted into the database alongside the part of the value that I actually care about. And then once you URL encode this, all of it, URL encode all, you can just do key characters actually, it doesn't matter. All right, we got a new message posted, and we should have a value of 1 as the value of the HTTP. All right, there you go. So, okay, I just selected a 1. That's not very useful. I could totally replace that with something like version, which on MySQL allows you to select the string value of what the version of the current database is. If I refresh here, I am running 5.5.47 Ubuntu. So that is the version of the MySQL server that I just ran a SQL injection against. Okay, so that's okay, but what else can I do? I control this entire subquery. I can select whatever I want as the value of my body now at this point. So this is an example of a second order HTTP or a second order SQL injection because I have to make one HTTP request, but the value of that SQL injection does not get returned back in the response that the server sends me. I have to go visit a second page in the web application in order to get the value that I just persisted to the database, which is why it's called second order. Instead of just making one HTTP request and then looking for my extracted value in the response, I have to make the HTTP request, then make a second one to a second page, which should contain the value that I just persisted. Okay. So now that I have that, I can actually begin to select email. Let's see. What was the? It is name and password. I think from GDN users. Let's see if I can remember this by limit. One side effect of using a subquery is you can only return one row at a time. If you tried to return more than one row, you would get a subquery returns more than one row error in your actual response instead. Okay, so select from GDN users, limit 0, 1. Let's see if that works. SQL syntax error. Damn straight. Okay. Select name, password from GDN users, limit. Oh, I see what it is. Okay, I don't need to have that comment there. Oh well, whatever. Anyway, so this is if this were working. Oh, and you know what? I need to concat this as well. Select concat because I can only select one value. I can't select two values. That doesn't make any sense. So let's try that. Nope, still not. Table vanilla GDN user. I'm an idiot. GDN user. There we go. Okay, so now I got my new message that was saved there. And so this next one should contain the password, the username and password hash of the admin user. Okay, so there you go. So in order to fully exploit this, you actually, SQL Map has a great deal of trouble actually exploiting this vulnerability because it is a second order vulnerability. It can find a Boolean-based injection in the single HTTP request, but obviously Boolean-based injections are quite slow compared to what I can do here. I can select all the values I want and just stick it in the body of my message, and then make an extra HTTP request to get it out. But I can do a little bit with SQL Map in order to have it detect this vulnerability. I've got 17 minutes. I may finish up a little early, but that'll be okay. So let's go back to SQL Map. Let's look at the HTTP request that I have on the. I saved that vulnerable HTTP request to the file system. temp/talk/vanilla.rec. Okay, so if we look, I basically have that first payload that I used where I selected one. You can see where I'm highlighting text up there. Where I select one from Dual. That was my original payload that I used to just verify that I was selecting, I was controlling the data that was in the body to be posted to the message thread. But I use a special thing in here. I use an asterisk, and I talked about an asterisk earlier during my talk over at the Alamo Draft House. The asterisk allows me to tell SQL map, don't try and parse anything in the HTTP request. Don't try and parse the post parameters or anything. I want you to just look for SQL injection in this specific spot right here. And it's a very powerful feature of SQL map that allows you to have a lot of flexibility in where SQL map is going to be looking for SQL injections. So in order for SQL map to be, since this is such a bizarre syntax for SQL map to try and auto-detect, I can't just give SQL map the raw HTTP request that we had that the application was making. So if I go here, SQL map is not going to know to add square brackets to the body parameter in order to induce the error to begin with, and it's not going to know how to auto-complete this insert statement for it to automatically be able to save information and take advantage of the database. So I'm going to have to basically fill that all out for SQL map and then tell SQL map, okay, now that you have a vulnerable request that's useful for you, now you can go ahead and start trying to find ways to exploit it that you wouldn't have had otherwise. So that's what I do, is I basically fill out everything as if I were going to attempt to try and exploit it, and then I just put an asterisk inside of the HTTP request for SQL map to look for. And then, once we do that, SQL map is able to partially detect and exploit the SQL injection. There we go, right there. So as you can see, SQL map has detected that the custom injecting marking character asterisk was found in the option data. It wasn't technically in the dash data option, but it was in the HTTP request that I passed it using -r. So I'm going to tell it, yes, I want you to just focus on that, ignore anything else. And I did this earlier, so I cached it. But it's obvious SQL map is able to determine that it's a Boolean. It can do a Boolean-based injection. It can do an error-based injection, or it can do a time-based injection. However, none of those are the subquery injection that we were able to use in the second order way. All of these are going to be slightly slower than actually implementing an actual exploit to take advantage of the SQL injection, to the second order SQL injection. But using that, we can still take data out of the database. It's a little bit easier. So there, that was not cached. SQL map just automatically was able to, it used the error-based injection, it looks like. Is that true? In fact, if it did, and if I've got a little bit of time, I might pass that through Burp Suite so you guys can see what an error-based injection looks like. Passing SQL map through Burp Suite, if you ever want to know how SQL map is exploiting a SQL injection or what it's doing differently than you are, you can pass Burp Suite through, or pass SQL map through Burp Suite, and everything's going to be recorded in the HTTP history. So you can easily look and see what SQL map is doing that you may not be in order to exploit a given SQL injection. All right, keep going. Yep. All right, so let's go back to Burp and let's see what those SQL injection HTTP requests looked like and what those responses looked like. So we can see now SQL map basically came out with this entire body thing right here. This is the entire payload that SQL map came out with based on the HTTP request that I gave it that was already pre-populated with some parts of the SQL injection. URL decode, and you can see now, instead of just doing select one from dual, SQL map is adding in this payload, select one from dual and select all of this crazy stuff just in order to determine the value of a given character inside of the data that it's trying to glean information out of. And so that's where the rest of the SQL query begins. And this is where I started. So everything in between was automatically created by SQL map. However, it still would not be able to exploit the second order injection, which it would definitely be more efficient from an attacker's standpoint. Let's see, and I think that's it. I think that's all my talk. Let me make sure. Yep, so something to keep in mind in these modern web applications that you're testing with weakly typed applications, definitely don't just focus on the SQL aspect, focus on all the aspects. You've got a SQL server that's running on a file system that may not have properly configured access controls. You may be using a language in order to persist data to the database that doesn't actually care what type of the data it is, and you can determine what type it is and take advantage of that on the back end. I think PHP has multiple types of problems like this, and that's why it has both a 2 equals operator and a 3 equals operator, because it makes perfect sense, right? So anyway, that is the end of my talk. Does anyone have any questions? No? Okay. Well, thank you guys. I hope you enjoyed it.